Okay. Well, hopefully you're not going to see the fact that I just screwed up, and you only see this recording. I tried going quickly, and I skipped two things. Okay. So I've got some things on my screen I started writing about. Gosh, let's just pause here for a second. Okay. So this review is going to be partially me flipping through the book, partially me looking at the actual test, and just kind of making sure that we cover everything. Well, not everything. I'm not gonna bother telling you what typical values are. It's right in the book. I'm not going to tell you whether it's adjustable or whether it's determined by. That is all specific in the book. I shouldn't waste our time with that. It's all written down there for you. I just want to make sure that we're completely clear on the differences of what we're talking about here, and then I'll go over the test and point you in the right direction. So we have two representations of sound waves here. The bottom is a continuous wave at the bottom, and we have pulses up here. As you guys know, we've talked about this before. Pulses create images. This picture right here is a bit of a misnomer. It shows two pulses going out at the same time. There are situations where that happens, but in the most basic of ultrasounds, it does not happen that way. One pulse, all the echoes, then the next pulse. This time, this listening time from here to here, that is greatly increased when you go deep into the body. Deep in the body, you have to wait longer for all the echoes. So you have to listen longer. It makes perfect sense. Okay, so we have as I'm just kind of looking through the book really quickly, pulse duration is analogous to the period, pulse, or not pulse period, but the period of time for a single cycle. It's analogous to it. So pulse duration, we go from here to here, we're going to count pulse, we're going to count cycles, 1, 2, 3. I usually draw 3 cycles. It's just the way I do it. And then we're going to say how much time each cycle took. So 3 cycles, and it was period T, period T, period T. So we could add those together to get the pulse duration, or we could simply do 3 times the period. T for time is equal to pulse duration. All right. Spatial pulse length, same thing. I don't even have to erase some of my hash marks here. It is beginning to the end of the pulse. It is how many cycles? So we have 3 cycles. Oh, good grief, Kurt. 3 cycles times what? This time, it's not the period, it's the length. It's how long. Did I say spatial pulse length? Spatial pulse length. Lambda equals spatial pulse length, of course, all right? Or I could have said lambda plus lambda plus lambda, because it's 3 cycles. Once again, you guys can look up your normal values in there. Moving forward, because I want to spend a little more time on some other things. Pulse repetition period. Let's actually get rid of. Okay. Pulse repetition period is the time it takes, once again, pulse repetition period is time it takes, good Lord, to go from here, the beginning of one cycle, to the beginning of the next cycle. All right. Keep in mind, your book, your test, your SPI, I draw cycles going from left to right on my screen, as most people do, but for some reason, when they measure beginning of one cycle to the beginning of next, they call it beginning of cycle to the beginning of the next. In other words, they suddenly decided things move from right to left on the screen. I don't do that, but just be aware that could be. So if you really doesn't matter, as long as you're including one whole cycle, one whole listening period. Whether it's that, whether we say it that way or whether we say it this way, it's the same difference. It does not matter. It's just, I don't want you to get hooked up on something that doesn't mean anything really. So remember, this is your listening period here. Listening, reception. Can't think of any other terms right now, but you get it. And the pulse itself is talk. Whoops, you know what I meant. Talk time. What's the opposite of receiving? Transmit time. So that's going to bring us directly into, I think so far everything, this is pretty easy stuff. And once again, this listening time directly related, depends on how you say it. If I don't want to say directly or indirectly related, because it really depends on your English or which words you use. So I don't want to confuse that. Very shallow imaging, listening time is very short. By the way, that creates a more pleasant experience when you're watching the screen. You move the transducer and everything is instantaneous because there's very little listening time. When you're very deep and you have to listen, you cannot send out another pulse until all the echoes come back. You move your transducer fast, there's a lag on the screen. It's not pleasant to look at. Anyway, I digress. Pulse repetition frequency. Well, once again, it's pulse repetition period, pulse repetition frequency are what? Reciprocals, right? They are perfect reciprocals. So 1 over pulse repetition frequency. Whoops, I meant. Doesn't matter. It really doesn't matter. I could have written it that way, but I meant to do pulse repetition frequency is equal to 1 over pulse repetition period. In other words, when this goes up, this goes down, and it's a 1-to-1 relationship. It's not this one goes up and this one goes up 4 times, or this one goes down 4 times. It's a 1-to-1 relationship. That's really what this perfect reciprocal is all about. Pulse repetition frequencies are usually in kilohertz, by the way. It's thousands of pulses. So remember, thousands of pulses, which represent, because they take snippets of what would be a continuous wave, but it's not a continuous wave. It just takes a snippet out. That snippet represents, because it is of that frequency, millions of cycles per second, or millions of hertz. Okay, and I kind of wanted to zoom along until I got to the duty factor. That one I just want to make sure we're understanding. So duty factor. Remember, usually represented as a percentage, but it doesn't have to be. It can be a simple ratio. Is equal to the pulse duration, length of time that for that. So 3 times t, whatever t is. And so that's pulse duration in microseconds, right? Seconds. Oh, you know what? We're not going to worry about that. It's just better you don't worry about it for this particular case because it's microseconds and possibly milliseconds. So it gets pulse repetition period. That, remember, is that amount of time. So the small amount of time divided by the large amount of time times 100. So you have a small amount of time divided by a large amount of time. You're going to get a decimal point, 0.006 or whatever. And then you multiply by 100, that 0.006 now becomes 0.6%. So duty factor is on imaging, pulsed imaging technology is if you get anything other than a very small number, you're wrong. So it's a very small number or percentage, like 1% or less, even less than 1%. I mean, I'm not saying it can't be 2-3%, but it's certainly not 20%. And it's certainly not 100%. 100%. Continuous wave, 100%. Why? Look at this. Up here, you can't see what I'm doing. Up here, we divided a very small number by a large number. Or we divided this very small section of pulse divided by the pulse and all the listening time. Okay, so down here, where's the pulse? Where's the listening time? It ends out a duty factor just pretty much ends out to be 1/1 or 100/100, I guess. In either case, it does not matter. It ends out to be 1 times 100 equals 100%. So whether you think of it as 1/1 or 100% of the time over 100% of the time, divided by each other comes to 1, multiplied by 100 equals 100%. So duty factor continuous wave is 100%. Duty factors for pulse waves are very small numbers because, remember, just in general, 99% or more, I'm going to put a plus sign, is listening. So you would expect that usually your number, your answer for duty factor is going to be less than 1%. I hope. Okay. All right, so I just wanted to get some of that out of the way. Let me erase everything here. Okay. So, I'm sorry, I lose my mouse. But I have to, seriously, here. There you are. Okay. Actually, on duty factors, I believe that is one of the things in the book. It should have a range that you should know. And it really helps to know the range. That way, when you're answering questions, you can get to that. You could eliminate maybe 3 out of the 4 if you're doing multiple choice. You might be able to eliminate 3 out of 4, or at least 2 out of 4, like that, if you know your range. I don't know. I do want to see something. Yeah. Okay. Understand, of course, just in general, if you have a high frequency versus a low frequency, obviously, high frequency, low wavelength. Low period T, low T, sounds like a commercial. And vice versa with the low frequency, long wavelength, long period of time. Everything travels at the same speed, at least the speed of sound is the same, but that's actually not in this test, that was last test, wasn't it? I love it. Okay. Actually. So, like I showed you before, though, with your pulse, look, if we ask you what the spatial pulse length is, you obviously need some information. We may give you the number of cycles. I don't think we're going to have to calculate. We could give you the number of cycles in a pulse and then have you calculate lambda to find the spatial pulse length. But once you do find that, of course, it's just, oops, in this case, sorry, 2 times, well, whatever lambda is. So just be able to manipulate them, the equations and numbers, a little bit anyway. Like I said, there are a couple of actual calculated problems on this, so I'll let you have a calculator. I'll put that out there. Anyway, fraction. See, I almost just repeated the actual test question. Definitions. A little bit of calculations. So these, these, spatial pulse length calculation or pulse duration calculation or duty factor, be able to do those. We will have you use a calculator in this test. Yeah. Oh, of course, now we get into chapter 5 have the intensities, right? There's spatial intensities, temporal intensities. Remember, a spatial intensity that's not too bad, actually. There is my cross section of my beam. My sound beam, of course. Intensity, oh, what's that? Spatial peak, right? SP. Intensity SA for average. All right. Now remember, when we put these together, I say it's we put our spatials first. So when we put this together, we're going to put an intensity S something. Let's say SP. All right. Now, second part of that, we need to know in time. So these are spatial. Spatial. It's special. I'm special. And then there's, well, peak intensity or intensity temporal peak. Intensity temporal average. I'll just say the temporal I'm sorry to say temporal average. All right. Sorry. Peak pulse average. Jesus, Kurt. Intensity pulse average. I'm sorry, I said that wrong. Because the temporal average, averaging intensity during the entire pulse repetition period, I'm not even going to attempt to draw everything, but just remember that that one includes all pulses over all of time, average temperature, average pulse strength is going to be really weak because remember, 99% of the time we're listening. So the intensity TA, temporal average, is very, very low. That's so very low. Okay. Let's see, what was the most important one? Well, the strongest one, the intensity, spatial peak, temporal peak. Imax is just, IM is, that's an oddball. Don't worry about him. He's, you did this. The lowest intensity would be spatial average, temporal average, SATA, salto. And then the, what was the most useful one? I actually forgot. I'll be honest with you, totally forgot. Of course, I read it completely backwards to find it. Let's use a different color. Intensity, spatial, peak, temporal, average, most important for bioeffects. Okay, let me see what else is on the menu here. There's a couple fill in the blanks. It's fill in the blank, but it's still multiple choice. When you do those, so there'll be like a sentence, blank, and finish the sentence. Go to the first blank. You should be able to answer it, or maybe the second blank. I guarantee you, right off the bat, you're going to eliminate 2 of the possible answers. I don't guarantee you, but you're probably going to eliminate 2 possible answers. Then you go to the second blank, and you eliminate the last one. Numbers that you should just memory. Yep. Yeah, there's some questions in here that are, it's the same exact information. Trust me, guys, the same exact information. They just come around from a completely different angle and ask it backwards, and everyone flips out. It's not. Don't flip out. Same question or same subject that we've already gone through. Okay. I'm pretty satisfied. I'm satisfied that I'm going to pass it. So intensities, pulses, measuring pulses, duty factor, relationships. What if something goes? SPI loves relationships. If one value goes up, what happens to the other value? Maybe that goes up as well. Maybe it goes up a lot more. Or conversely, one value goes up, another value goes down. All right. Try to remember those types of relationships. It's really important. And a lot of times, of course, it's in our X, Y, Y. Why did I use X? Let's just do A equals B over C. Just remember those relationships are pretty easy. That goes up, that goes down. B goes up, A goes up. All right. So if you have a formula to work with, think of that all the time. If you don't have a formula, just remember the basic relationships, indirectly or directly related. They always like those questions. Okay. I don't want to waste any more time. It's taking an unbelievable amount of time for this to, it has to go from recording on the computers to reformatting it, and then it goes up to YouTube. It takes hours. So I'm going to shut up now and best of luck to all of you. There are currently 30 questions, although I noticed one was repeated, so 29 questions currently. A minute per question plus some, so it won't be an hour. Probably a 40-minute exam, probably. All right. See ya.